All right, so we've seen the basics of decorators. I promised I would show you some examples that would actually be useful rather than just greeting or uppercasing things. So the first example I'll show you has to do with benchmarking or speed testing our code. Back in the generator section, I don't know if you made it through that section, first of all, but if you remember, we saw the difference between doing something with a list comprehension, like x for x in range 100, versus doing it with a generator expression, where no list is actually created. Here, the entire list is created and then summed. Anyway, if you have questions about the differences in what a generator expression is, go back and watch the generator expression or the entire generator section. But remember the code that I used. I basically imported time, and then I was doing something like start time equals time.time, and then time.tim, and then I would do the code, and then afterwards I would do, total time equals time.time minus start time. Okay, and I did this for in this case for two things to compare them, and I had to write that code out twice. I had to assign these variables each time. It cluttered up my code a lot, not to mention the print, where I was doing a print statement that said something like, it took 4.2 seconds, or whatever the print said. This is a great use case for a decorator, because all I wanted to do is basically wrap my function call with the speed test code. So we could get rid of all of this, comment this out, or delete that to start. Let's do as the comment says, define a speed test decorator. So the first thing we could do is just define speed test. And the whole idea is that I should be able to do something like, def sum nums, and then in there I put some code, but in front of it I should be able to say I want a speed test on this, and then down here I could have another one, I want a speed test on that. For that to work, we need to define speed test, fn, and the first thing we should do is define wrapper, and the default should be args and then quargs, as we saw, was that the last video, 2 videos ago? And then we should get time in here, so we need time. But the thing is, we only really need this time method on the time module, so let's do from time import time. So now I can do something like t1 equals time instead of time.time. Then we're going to run the code. So that would be, I need to indent this. That would be something like result equals call fn with args and quargs. So we're capturing the start time. Then we're running the code, whatever the function is. And then after that, we're going to capture the end time. I actually prefer start time, even though it's longer, and end time. Okay. And then we'll want to do something like print. And what do we want to print? Let's do an f string, and let's just say time elapsed. And the calculation is simply end time minus start time. And then of course we do need to return the results if we want to do something with it. And then we return wrapper. And we should just add in wraps. So from functools import wraps. If you're not clear on what this is, go back and watch that video. It's kind of boilerplate at this point for any decorator function that we define. Okay, so looks good. Let's test it out. Am I missing anything? In all likelihood, yes, somewhere. Let's do sum nums, and it should just be a really simple function that returns, let's do sum and use a generator expression, so we don't need anything in there. Let's do x for x in range. We'll sum the first however many numbers that is. Okay. And this should work, except we need to call it print sum nums. Let's give it a shot. No! What's the problem here? Oh, I was missing a colon. Typical. Try that again. There we go. So now we get time elapsed 0.104 blah blah blah. We could have this round and not have such a long string here of numbers. And then here's the return value. The first, was it million digits summed together? Awesome. So we've created this pretty simple decorator that is really easy for us to use and just throw on to any or put in front of any function and have that function speed tested. It's not the most accurate or precise way of benchmarking, and we're not, checking things like memory usage. It's purely about time, but it's close enough for what I want to show you. And to test it out again, let's do the same thing, except let's do one with a gen and one with a list. And so in the gen one, we'll leave it alone. The list one, however, we'll use a list comprehension right here. Turn it into a list first. This should be a lot slower. And instead of 1 million, let's do 50 million, like that. And then let's print some nums gen and then list afterwards. The only thing that would be nice right now when we run it, it will just say time elapsed and then time elapsed, and it won't be clear which is which. I mean, we know the order that they're called in, but if I do it, it takes a moment too because we're doing 50 million digits now. Okay, so that was the first one. I believe generator was first, and then this was the second one using a list. You can see it was definitely slower, but it would be nice if it told us which was which, and that's not hard to do. All we need to do is, we could do it here, print, do an f string, let's just say executing, and then the name of the function is just fn.dunderName, and then let's increase the stakes here. Let's do 90 million. How about that? And the difference should be clearer now. Okay, so it might take a moment, a couple seconds for each. What do I talk about? Okay, 5.9 seconds for when we use the generator. And come on, you can do it. 8.6 seconds when we used a list comprehension to get the exact same result at the end. You can see the numbers are identical that we get back. This one took 8.6, this one took 5.9. Big difference. Okay, the point of the video was to show you that we could benefit from making a generator in a situation like this, where we're taking code, putting it on one side of a function, and then calling it after, and we're doing that a couple times. Why not make it into a generator? Our code looks so much cleaner now. And this is nice and easy, right? We just put speed tests in front of whatever we want. It's beautiful, absolutely majestic compared to some other programming languages. So cool stuff.